Welcome to this next session on our substitution reaction. We have already visited in our previous sessions that what are the substitutions reactions, especially types we have discussed, Sn2, substitution nucleophilic bimolecular, as well as Sn1, which happens to be substitution nucleophilic unimolecular. So basically for these kinds of reactions, we have generally visited the types and etc. And in the last session, we very quickly have visited the concern topics about the types of this substitution nucleophilic unimolecular. So what are the experimental evidences for substitution nucleophilic unimolecular reactions? So basically there are three major these types. That rate of the reactions is dependent upon the concentration of alkyl halide, the rate of the reaction which increases as the branching of the, alkyl halide increases, means the rate of the reaction is faster with tertiary alkyl halide or Sn1, then secondary, and then it comes to the primary one. Sn1 reaction, which is this we have not seen, but we'll visit this today. That Sn1 reaction is basically that will proceed through the formation of racemic mixture formations. This is the reaction coordination diagram for any Sn1 reaction. At the rate reaction starts from alkyl halide and water, and the final product may be, let us say, alcohol, hydronium, and the living group. So when it will pass through this, before the formation of alkyl halide, there will be certain transition state, and this will be a slowest step of the reaction, and that happens to be the rate determining step of the reaction. Then this is a carbocation intermediate which is formed, and carbocation intermediate which is reacted with this water molecule, and that will form after the loss of proton. It may form alcohol. This is what the reaction is explained in terms of whenever a free energy of the reactants, intermediates, the transition states are plotted against the reaction. This is another reaction slide where it has been displayed that how tertiary alkyl halide is converted into tertiary carbocation, which is slow, very fast manner. It is attacked by this water, which act as a nucleophile, and that will form this hydronium ion, and the loss of proton, which is again a faster reaction to form this tertiary butadiene. What are the influences for the several these things? So as we have seen in case of Sn2, the similar diagram is also available for Sn1 reaction, where the reaction is faster. As you can see that if it is considering this methyl bromide or primary or methyl alkyl halide, the rate of the reaction is too much faster with tertiary alkyl halide, and that is roughly 10 times higher than is primary in case of secondary alkyl halide. So why such thing is happening? This thing is happening because after the loss of proton, after the loss of the living group, it may form some alkyl. It may form a carbocation, and carbocation is easily stabilized when it is further conjugated with more and more alkyl groups. So friends, with respect to this, we have to understand the stereochemistry point of view, the stereochemistry aspects of the substitution nucleophilic unimolecular reaction. So what are these aspects? Let us learn them first of all. Here you can see that carbocation reaction, basically after the loss of a living group, this will be forming a carbocation. And if you remember, the carbocation that possess sp2 hybridization, and sp2 hybridized carbons are always linear. I will say sp2 hybridized carbons have planar geometry. Just like if you remember alkene, so alkene possess sp2 hybridization along with this, let us say, trigonal geometry. So similarly, this is also kind of trigonal geometry where bond angle is 120° and molecule happens to be planar. They exist within single plane, and planar molecule is existing. So what can happen over here that this water may attack either from the side A or it may attack from the side B. As you can see on this reaction that A and B, basically these are the trajectories of water to reach to the carbocation. So don't option it. Since it is a planar molecule, water may attack from this side. If water may prefer not to attack from this side, it may attack from other side also. So similarly here also this what carbocation is attacked either from this side or from the backward side. You can call it as either front or the backward, or you can call it as either lateral or other sides as well, opposite side. So what will happen that if it attack from a side A, then it will be attached to this side, likewise this one, if it and so a new product is formed. If this is attacking from other side, the opposite side, then water will be attached to this portion. So point is that basically the two products will be formed after the loss of proton. That if water is attacking from this side, then this enantiomer will be formed. If it is attacking from the side B, then other enantiomer shall be formed. Okay, so stereochemistry point of view, here we are obtaining two products rather than a single product. So that's why, let us say if this enantiomer is dextro, then other enantiomer will be levo. If this is capital R, this may become capital S. So that's why R and S, dextro and levo, this can form, if you remember our classification of isomers, then it can be called as racemic mixture. So the stereochemistry point of view, it is going to form the racemic mixture. A perfect example for this has been highlighted, which I have taken from Organic Chemistry by Bruce. Pearson Education is the publication house. So in this book, the same example, the same diagrams are available where it is mentioned that as form of 2-bromobutane, which reacts with water in under Sn1 conditions. Methanol is a solvent that will form two different products. One product is called as R, another product is called as S. तो क्या होगा कि जो भी रोटेशन R आइसोमर करेगा उसका exactly opposite rotation will be done by the S isomer. So thus R and S, both the isomers, they shall try to counter cancel the optical rotation, and overall the molecule will become optically inactive. So that is the specificity of the racemic modification. Now let us learn further that what kind of things are more important, because these molecules are generally having different kinds of tendency to interact with each other. Look at this one, where in Sn2 conditions, there was a concept of basically our objective is that we wish to compare the Sn2 reaction versus Sn1 reaction. Substitution, nucleophilic, bimolecular, substitution, nucleophilic, unimolecular. So देखो, this is the same isomer, which is basically, if you remember the cyclohexane का जो nomenclature we have learned in previous sessions. So where the cis isomer of 1-bromo-4-methyl cyclohexane, if it reacts with hydroxide in the presence of Sn2 conditions, then it is going to form this trans isomer. But the same isomer, if it reacts with water under Sn1 condition, substitution, nucleophilic, unimolecular, then it will form this trans isomer, basically trans 4-methyl cyclohexanol. And along with that, trans cis isomer will be formed. क्यों ऐसा? क्योंकि Sn2 में जब Br इस साइड से अटैक करेगा, so basically, मानो कि this is at the front side, so it will attack from the back side, and when it will attack from the back side, so it will be attached to the backward position. But in Sn1 condition, after the loss of this bromine, it will form a carbocation. Carbocation happens to be a planar molecule. So water may attack either from the left hand side. If not feasible, then water may attack either from right hand side, and it can form two different isomers. Left side attacks एक isomer or right hand side attacks a दूसरा isomer. So that way, two different isomers can be formed in Sn1. The same isomer here there was Sn2 condition which required the presence of strong base. This is Sn1 condition which does not require the strong base, but simply the reaction may proceed in the presence of water. So rate of the reaction is basically affected by, we have also seen the factors affecting Sn2. So similarly, like here also factors affecting Sn1 are there. The better the living group, faster is the rate of the reaction. Better is the more stable carbocation, faster is the rate of the reaction. The polarity of the solvent. This we have also discussed, because the reason for this is that, as it is highlighted over here, that Sn1 reactions are those where the intermediates formed. These are generally positively charged species, carbocation, which has positive charge. And there is a concept which is called as like dissolves like. उसका मतलब ये होता है कि जो जैसा होता है उसको वैसा मानना, right? So basically, positively charged carbocation will be easily solubilized in polar protic solvent, which have polar functional groups. ये देखो, if there is a positive charge, then this positive charge is easily solubilized, or that can be formation of this ion dipole interactions. It can be hydrogen bonding interaction also through, क्योंकि यहाँ पे जो डेल्टा partially negative charge is present on the head of the oxygen. So this positively charged carbocation is easily solubilized in polar protic solvents such as water. Water is a polar protic solvent because it possesses positive, it can possess H plus and OH minus. That's why it is polar. It is protic solvent क्योंकि वो H plus release करना जानता है. इसीलिए water happens to be the polar protic solvent. So that's why, let us say if we have H plus and OH minus, so H plus can be easily solubilized, where H plus will have a positive charge, OH minus water के जो negatively charged oxygen है, that will help to stabilize. And if we have OH, this other intermediate, let us say our negatively charged, our living group. So living group जैसे Br minus है, so it will be stabilized within polar protic solvent with the help of water molecule. So hope that this diagram which is there in P.Y. Bruce's book may be helpful to you for further understanding of this thing. And because of this, as you can see, that when we perform this reaction in two different solvents, more polar solvent and less polar solvent, so जो more polar solvent है ना, that may require less amount of energy, free energy, क्योंकि ट्रांजिशन स्टेट अच्छे से स्टेबिलाइज होगी. So that's why this happens to be a progress of the reaction which can be good to stabilize the transition state. Okay, so these are the reactions which we have on factors affecting some of the concepts which we have visited in our previous sessions through different modes of other slides. Now in this session, we are going to learn further that what are the other factors affecting substitution reactions and what can be the other phenomena which can occur when a substitution reaction is in progress. So friends, when this Sn1 reaction is there, so generally here there is an example of 2-methyl bromobutane. Already things are already there on the slide. So what we may assume that 2-bromomethyl butane, which is happens to be here secondary in nature, because this carbon which is present CH, so CH carbon is further attached with two different alkyl groups. One of them is methyl and other you can call it as isoprofile. So that's why it happens to be in secondary nature, and after the loss of this proton, after the loss of this living group, it will form this secondary carbocation. This secondary carbocation will be attacked by the group, will undergo 1,2 hydride shift. Now, why this shift is essential during why it happens? Because to affect the stability. Just like human being, you people may be learning, but some, if you have seen that people have been admitted in PharmD first year or in some other class in the first year, and they found that they have option or a scope to study MBBS in some colleges other than this. So what they do that they abandon the PharmD program and join for MBBS program in other colleges. Then the question is that why he or she is doing like this. Maybe the factor is stability. She may feel that after doing, or he may feel that after doing MBBS, there is a lot of scope. So why I should study PharmD? Let me go to do and achieve the MBBS degree. Similarly, this may be possible within other that why one should perform. So this other than other degree. So that is applicable to wherever that people like this, just like after passing from these institutions as a PharmD graduate, after 6 years, you have been offered a package of 6 lakh rupees per year by some let us say some pharma companies or whatsoever, CROs, clinical research organizations, etc. आपको 6 लाख का पैकेज दिया है per year. And after experience of 1 year or 2 years, some other company offer that can you join and our company, we will offer you 8 lakh rupees per year. आप 6 लाख की सैलरी का वो कंपनी छोड़ के हमारी कंपनी में आ जाओ, हम आपको 8 लाख का पैकेज देंगे. So naturally, you will be moving from 6 lakh of your company, your existing organizations, जो आपको 6 लाख का पैकेज दे रही है, उससे आप 8 लाख वाली कंपनी में जॉब करना प्रीफर करोगे. Why? Because you feel that money is a stability factor to you. With the help of achieving more money, you may be able to satisfy your daily, personal, or family needs with this. So that is your stability concerning for this. So if human being can have such kind of stability, 6 से 8 MBB formed is MBBS. So similarly, molecules, they are nothing but they exist in our cells. Our body is also made up of molecules. So molecules also have similar tendency. What kind of tendency? Let us see over here. Here it was a secondary carbocation. Why it is secondary carbocation? Because ये जो CH plus containing carbon है ना, वो दो अल्काइल ग्रुप के साथ जुड़ा हुआ है, मिथाइल और दूसरा है आइसोप्रोपाइल. तो आगे चल के 1,2 हाइड्राइड शिफ्ट होता है. 1,2 हाइड्राइड शिफ्ट में ये जो हाइड्रोजन यहाँ ये जो हाइड्रोजन यहाँ पे आइसोप्रोपाइल कार्बन पे था, वो वहां से मूव होके एडजेसेंट कार्बन पे चला जाता है. तो यहाँ से वो बाजू वाले कार्बन पे चला जाएगा टू द नेबरिंग कार्बन, देन यहाँ पे पॉजिटिव चार्ज आ जाएगा और ये CH का बन जाएगा CH2. तो अब देखो, इसको बोलते हैं 1,2 हाइड्राइड शिफ्ट. हाइड्राइड शिफ्ट इसलिए बोलते हैं कि जो हाइड्रोजन का शिफ्ट है वो अपने लॉन पेयर लेके घूमता है H माइनस. ये जो H माइनस है ना, वो बाजू वाले H कार्बन पे जाता है तो उसका जो प्लस है चार्ज है वो 0 हो जाता है. पर यहाँ पे एक डेफिशिएंसी हो जाती है, एक लॉस हो जाता है, इसीलिए आइसोप्रोपाइल वाले कार्बन पे यहाँ पे पॉजिटिव चार्ज आ जाता है. तो ये जो पॉजिटिवली चार्ज कार्बन है ना, इट हैज फ्रेंडशिप विथ 3 different carbon. One of them is methyl, other is also methyl, and third one is ethyl. So that way it is tertiary. So 1,2 hydride shift that happens to be a stability factor. क्यों? क्योंकि आपको पता है कि सेकेंडरी कार्बोकैटायन से ज्यादा स्टेबल इज टर्शरी कार्बोकैटायन। एंड टर्शरी बेसिकली 6 लाख वाली बात और 8 लाख वाली बात, तो यहाँ पे 6 लाख था सेकेंडरी कार्बोकैटायन, 8 लाख हो गया है टर्शरी कार्बोकैटायन। And we know that tertiary is more stable. So that's why 1,2 hydride shift will generally convert the secondary carbocation into tertiary carbocation, and बाद में water का attack होता है, loss of proton होता है और ये product मिलता है, which is none other than 2-methyl-2-butanol. So whenever there is a formation of carbocation, we have to see for this kind of 1,2 hydride shift, that is there any probability that secondary carbocation can get converted into this carbocation or tertiary? No, not. Primary भी secondary बन सकता है, secondary may undergo to tertiary, so these kind of transformations are possible. If this has undergone, let us say Sn2, then it may form 3-methyl-2-butanol. But देखो यहाँ पे Sn1 reaction में it is totally opposite product, 2-methyl-2-butanol. So different products formation may be occurring. Why? Because tertiary formation of carbocation, and this carbocation may be undergoing rearrangement to get further stabilization. So these things are possible with the molecules also. We will also visit such kind of transformation in our next unit, which is called as elimination reactions. उसमें भी even reaction जहाँ पे carbocation बनता है. So we'll visit the same thing in other coming sessions. So benzylic carbocation and allylic carbocation. So these are the reactions where Sn2 reaction में बोला है कि they basically undergo aprotic solvent and good nucleophile. So simply Cl का replacement करके they may form this methyl ethyl ether and this 2-butanol. So tertiary benzylic and tertiary allylic are basically Sn2 reaction because of the steric inherence. So they can undergo either any of the reactions, either Sn2 or Sn1. There is no more difference. Okay, now I shall go further to explain you people that what is the difference between Sn2 reaction and Sn1 reaction. So this is it has already highlighted. There are 7 points have been explained on the present slide, which indicates the difference between Sn1 reaction and Sn2 reaction. Sn2 reaction is basically one-step reaction which can be completed within a single step. Sn1 reaction is basically two-step reaction, you call it as, because it involves the formation of carbocation and followed by the attack of the nucleophile. Sn2 reaction is basically bimolecular substitution, nucleophilic bimolecular reaction, and Sn1 reaction that happens to be a unimolecular rate determining step. In Sn2 reaction, there is no formation of carbocation, but however, in Sn1 reaction, dear friends, there can be possibility of carbocation. Here, there is no intermediate is involved. Here, the intermediate is carbocation. Fatter is a nucleophile, the faster is the rate of the reaction. But let me tell you that under Sn1 reaction, the rate of the reaction is not affected by this press, whether it is a strong nucleophile, whether it is a weak nucleophile, because the rate of the reaction is independent from the concentration of alkyl halide. The reactivity order that for Sn2 reaction, methyl is faster than primary, then secondary and tertiary, and reactivity order for Sn1 reaction where tertiary is more faster than secondary and then primary. Methyl will be observed at the later. ऐसा क्यों होता है? Because for Sn2 reaction that sterical hindrance is a key factor. जहाँ पे sterical hindrance कम है वहाँ पे fastest reaction होगी, और Sn1 में उससे Sn2 से एकदम उल्टा, जहाँ पे सबसे ज्यादा steric hindrance है वहाँ पे सबसे ज्यादा stability होगी and the reaction will be faster. Sn2 reaction where umbrella inversion, Walden inversion is possible, where जहां जिस साइड से न्यूक्लियोफाइल अटैक कर रहा है उसी साइड से वो अटैच होगा और बाकी के पक्ष दूसरी साइड पे अटैच हो जाएंगे, जस्ट लाइक अम्ब्रेला इन्वर्जन. But SN1 may nothing is like that. Carbocation is formed, and this carbocation may be attacked either from right side or left hand side, and two different products will be formed. Living group ability, as you can see, as such, there is no difference in living group ability. Iodide is a stronger living group, and similarly, this is also a living group. So this cannot, you can call it as a difference, but difference, yes, basically we can call it as a comparison that both have similar tendency for either for SN1 or SN2 when we consider the living groups. So summary of the alkyl halides, then when we have tertiary benzylic or tertiary allylic and tertiary alkyl halide, SN1 is more popular, but when we have a methyl or primary alkyl halide, then SN2 is there. But when we have tertiary alkyl or this kind of group, then mixed kind of reactions is possible for this kind of substitution reaction. Aryl halide generally does not undergo SN1 reaction or SN2 reaction. For separately, they have specific reaction mechanism which is called as substitution nucleophilic uh, SNAR. So that SNAR reaction, which basically it is a separate other reaction SNANR. So ये जो vinyl and alkyl halides, they probably undergo this kind of reaction. I repeat their names that they are basically substitution nucleophilic unimolecular reactions, and neither they follow SNAR, SN1 or SN2. So why? So that we will see in our future coming class. So with this, we'll stop myself up to this, and we'll keep learning and keep continuing our discussions on the same. So thank you all. Thank you so much.